since this is your review, you tell me if there's any problems. And the determinant, make sure you're able to do a 2 by 2 by hand. I want to see that you do this. This is what I want to see. Go up, whether you do it up here or down there, I don't care. But I want to see the work for the, excuse me, for the determinant. When it's a 3 by 3, 4 by 4, put it in your calc. We don't do those by hand.
Do you have to put that 8 times negative 14? You just go straight to negative 32 minus 10.
Yeah, that's fine too. Yeah. Well, whether you do this, I just do this so that when you're looking at your work, if you don't get the same answer, this way I try to like write them out. All right, and this is important. The most important part about the triangle is that you fill the right side with ones. Make sure it's got to be a square. So once you put your coordinates, here's your coordinates. Fill the right side with ones, and isn't that a nice way to find the area of a triangle, given 3 vertices? Much nicer than finding the distance formula, finding a line that makes an altitude, finding that distance. I just ask you to solve using your inverse. When you solve using your inverse, this is what I expect. I expect you to give me the original coefficients, the constants. I expect this right here. You don't have to give me the inverse matrix, because that's just kind of a waste of time. You can just say a to the negative 1. Oh, thank you. Or you one or whatever. So make sure you give this to me. Make sure, I just don't see this as an answer. Make sure you list it out. Again, if it doesn't have an inverse, you say no inverse. Again, I want to see your coefficients, and I want to see your constants, this and this. I mean, these are pretty easy to put into your calculator. The hardest part is showing me your work. So make sure I get work. Then I'll ask you to do the same, solve a systems of equation. I'll ask you to go back and do the same thing like this. And I'll say solve this with Kramer's rule. I'll do the same thing on the test. The nice part about doing that is you get the same exact answer. So should something go wrong, it's kind of a little bit better to try to backtrack. So separate them out. Make sure I see all your work. If I don't see your work, if I don't see these being replaced, you're not going to get credit. So don't just replace them in your calculator. Show me in your work. Otherwise, I can't give you full credit for it. And they should come out to be the same answer. Questions? Everybody can do this okay? And here's your Diophantuses. And again, you don't have to write out your whole table. Just somewhere tell me what your value of z is going to be. Just tell me what your value of z, which ones you're looking at. You don't have to write the whole table with blanks in them. Just fill out the ones that work. And then remember to give me a solution. And your solution has to be x, y, z. So just be careful because that's a different order. This is z, x, y. So give me your x, y, z order. All right, so Diophantuses say, build an RREF, flip these two fractions. Don't get, round your decimals. Build your equations for x and for y. X equals, y equals, based on the z. So here's my x equals, my y equals. Then take whatever is this argument here and set this greater than 0. Remember, it cannot be equal to 0. That's going to help you figure out where do your z's go. And then the easiest way, plug this in your y1, plug this in your y2. Make sure there's no fractions, no negatives, no zeros, no decimals. Yes.
For the let statement, I did the other way around.
You can do whatever you like, as long as your answers match what you give me as your let statement.
But the X, Y, Z, it's flipped for me.
Wait, say that again?
It's flipped for me. Because I got like 2, 16, 20.
Right, because I'll have to follow the way you set up your let statement. I'll follow your let statement.
Right.
You did large, medium, small. I'll follow your let. That's why your let statements are important. Can everybody do this? Good?
So if you set up, like you said, if you set up the let statement different, does that like change?
Not at all, because I'll follow the way you set up your solution. It's going to have to follow the way you set up your let statement. So if you said that X was large, and then Y is medium, and Z is small, however you set it up at the end should match your let statement. You're fine. Because your equations are going to be in a different order than mine. I set mine X, Y, Z. Small, medium, large. You probably went by this statement, right? Large, medium, small? Yeah, that's fine. Okay. Then you have your 5 coming first, your 3's in the middle, and then your 1's there. So all that switched is your X and your Y and your Z. That's fine. That's why you give me a let statement. But what I'm saying is just make sure you take it out of this table and into a solution. The table is your workspace. This is your solution down here. Even though there's quite a few of them, you have to give them to me. Good? Okay, let's go on to the next one. This should be a nice little test. Really no surprises in this. And I gave you a heads up on your word problem, so this way when you look at the word problem you won't think there's a mistake where you can't get 3 equations and you only get 2 equations. Okay, so we just have to know, can we do the following things? And if we can, multiply them out or do whatever it is asking you to do. So again, be careful of your dimensions. My A is a 2 by 3, my B is a 3 by 1, so the 3's hit together, and I result in a 2 by 1. This is undefined, so I can't multiply these. Remember, they're not commutative. It might be, if it's a 3 by 3 and a 3 by 3, obviously it would be, but they're not commutative. They have an associative property, but not a commutative. The only one that has commutative is what? It will adding, subtracting, adding, but what else? When you multiply. It's the only one, the inverse. The inverse has the commutative property. So when you do an inverse, you have to do A times B, B times A, and show that they're both the identity matrix. That's your inverse. To do an inverse, just take your matrix, click on the inverse symbol. Remember to flip them back to fractions. When you see the bars, what does the straight bars mean? Determinant. Good. I had you use Kramer's rule for this. You feeling Kramer's rule out there? Come a little bit in. Everybody good with Kramer's rule? Make sure I see all of those matrices. Okay, and then we have diophantine coming up, a couple of them. You have nickels, dimes, and quarters, but you only have 2 equations. And again, however way you set up your let statement, that's how I'll look for your solution. I need to see a solution. And somewhere, remember, somewhere tell me what your Z is going to be. Well, obviously this one only had 2. No fractions, no decimals, no zeros, no negatives. Good? Okay, and then here's another one. Pencils, pens, and rulers. Somewhere I need to see what your Z is, just right here. And then you don't have to fill your whole table in. And give me your solution. Something happened over here. Somewhere else. Something's off over there. I don't know what.
About 7 to 11.
I'm sorry?
About 7 to 11.
7 to 11?
Yeah.
Did you not flip this sign, or did this not come out to be a negative?
Because it's 0.5 Z plus 3, and you subtract 3, divide by 0.5, and then flip it, right?
Let's take this again.
No, you wouldn't, because
So you're
she has it.
saying add this to the other side.
Yeah.
Something happened to my work. It got pushed on top of each other. Okay, it's here though. So subtract 3. Oh, when you divide by a positive, but this side's a negative, don't flip your sign.
I got Z is greater than 6.
Yeah, but don't flip your sign. What happened to your negative 3? It should be negative 6.
Oh,
Yeah. So we really don't want that one. Don't flip your sign if you don't divide by a negative. If the negative's on this side, that's fine. And that's why I need to see your work. Because you don't want to lose points for the whole thing. You just want to lose a little point over here. But that probably is like a half a point.
No points.
Rather than missing your whole table. Usually if it's like a computation mistake, I'll only take off a half a point. In my heart, I can't take off a point. Because, I mean, we all make computation things. You're thinking, you're writing fast, you're thinking fast. I get the computation part. If it's a conceptual part, that's different. And if it's a serious one, like you crossed out a variable, or you didn't distribute, or you did a square and you didn't FOIL it out, that's a major. Like if you did this, and you gave me x squared plus 9, that's a major hit. If you did the whole thing out and this came out to be 6 over here, that's a half a point. Again, with the bars, determinants, and use the determinant to find the area of a triangle. Don't forget to fill it with 1. Good?
Yep.
Not a lot of surprises on this.
Oh, for numbers